Welcome back, everyone. Today we're taking a deep dive into something really important, engineering ethics.
Yeah, it might not sound as exciting as, like, self-driving cars or the latest gadgets, but trust me.
It's actually way more important because it gets to the heart of how those things are built and the impact they have on all of us.
Exactly. It's about the choices engineers make every single day.
So our guide for this deep dive is an article called Engineering Ethics Tutorial.
A great starting point. It unpacks some really tough questions that engineers face all the time, dilemmas.
Right, like those should I, shouldn't I moments.
Exactly. And these aren't just hypothetical thought experiments either.
They have real-world consequences.
Big time. So before we get into the nitty-gritty, let's break down what we even mean by ethics.
Yeah, because it's one of those words people throw around but might not fully grasp.
Right. So at its core, ethics is a branch of philosophy, like the study of moral principles. It's all about figuring out what's right and wrong.
Sounds simple enough, but I bet it gets complicated pretty quickly.
Oh, yeah. Especially when you start applying these principles to specific fields like engineering.
Okay, so that's where applied ethics comes in.
Exactly. It's like saying, okay, we have these general ideas about right and wrong, but how do they actually play out in a specific profession like engineering?
Gotcha. So it's like looking at ethics through a different lens, the engineering lens. But why is it so important in engineering specifically?
Well, think about it. Engineers are the ones designing and building the things that shape our world. Bridges, buildings, power plants, medical devices, the list goes on and on.
Right. They're literally shaping our physical world.
Exactly. And those creations can have a huge impact on public safety, the environment, even global progress.
So their decisions carry a lot of weight.
A ton of weight. That's why ethical considerations are so crucial in engineering. It's about making sure that those decisions are made responsibly.
Okay, so the article gives a great example to illustrate this whole thing. It talks about an electrical engineer working on a project to bring high voltage power lines to a remote community.
Sounds pretty straightforward on the surface, right? Bringing electricity to people who need it.
Yeah, you'd think it's a purely positive thing.
But there's always more to the story. What if those power lines pose health risks to the communities living nearby?
Oh, I see. It's like that saying, one person's trash is another person's treasure.
Kind of, yeah. It's more like one community's progress might be another community's risk.
That's a tough one. It's like every engineering decision has these ripple effects,
Exactly. And it's not always easy to see those ripples ahead of time.
which is probably why engineers need those ethical frameworks to guide them.
Right. They need a way to think through these dilemmas systematically.
So what does that look like? How do engineers actually tackle those tough ethical questions?
Well, the article outlines a four-step process, a kind of roadmap for navigating those tricky situations.
Okay, I'm all ears. Lay it on me.
First, they need to clearly identify what the ethical issues are, like what are the potential harms and benefits of this project.
Makes sense. You have to know what you're dealing with before you can even start to make a decision.
Absolutely. And then they have to gather all the relevant information, the technical details, the potential risks, the impact on different stakeholders.
So it's like being a detective gathering evidence before making a judgment call.
Exactly. Then comes the hard part, weighing the pros and cons of different solutions, considering all those ethical factors we talked about.
Trying to figure out which path causes the least harm, even if there's no perfect solution.
Exactly. And once they've made the best decision they can, they have to implement it carefully, thinking about safety, practicality, all those real-world considerations.
Because a great plan on paper doesn't always translate perfectly into the real world.
Right. And this last step is super important. They need to be transparent with the public, explaining their decision-making process and the trade-offs involved.
Transparency and communication. Why are those so crucial?
Well, for one, it helps build trust. People are more likely to accept tough decisions if they understand the reasoning behind them.
Right. It's like, even if I don't agree with the final call, at least I know why it was made.
Exactly. It shows that you're not hiding anything, you're being upfront about the challenges and the compromises.
Makes sense. But it still makes me wonder, why do engineers specifically need this extra layer of ethical consideration? What sets their profession apart?
Well, for starters, their work often has a direct impact on people's lives, sometimes in really significant ways.
Right, like those bridges we were talking about earlier. If a bridge collapses, it's not just a construction mishap, it's a potential tragedy.
Exactly. And the same goes for buildings, airplanes, medical equipment, you name it.
It's a huge responsibility.
It is. And beyond safety, Engineers also play a key role in shaping the future of technology, which has all sorts of ethical implications.
It's like they're not just building things, they're shaping the world we live in.
Exactly. So they need to be thinking about those broader impacts, the long-term consequences of their work.
It's not just about making something that works, it's about making something that works ethically.
Absolutely. And that's why engineering ethics is so important. It's about making sure that technology serves humanity.
And not the other way around.
Right. So the article dives into 7 key reasons why engineering ethics is so crucial, but we've touched on a few of them already.
We talked about public safety and making responsible decisions, but what else is on that list?
Well, environmental protection is a big one. Engineers need to consider the impact of their creations on the planet.
Right, because we can't just keep building things without thinking about the consequences for the environment.
Exactly. It's about sustainability, using resources responsibly, and minimizing pollution.
Makes sense. What else?
Well, another big one is fostering public trust.
Right, because if people don't trust engineers, they're not going to trust the technologies they create.
Exactly. It's about being transparent, being accountable for your actions, and building a reputation for ethical conduct.
So it's not just about building a bridge that stands up, it's about building a bridge that people feel safe driving over.
That's a great way to put it. It's about the human element, the trust factor.
Okay, so public safety, responsible decision-making, environmental protection, and public trust. What are the other reasons the article highlights?
Ensuring accountability is another key one.
Okay, so that's about taking responsibility for your actions, even when things go wrong.
Exactly. It's about owning up to mistakes, learning from them, and making things right.
No passing the buck.
Right. And then there's the challenge of grappling with the unique ethical dilemmas that come with new technology.
Right, because every new invention brings its own set of ethical questions.
Exactly. And finally, the article emphasizes the importance of supporting the personal and professional growth of engineers themselves.
So it's about helping them develop their own moral compass.
Exactly. It's about giving them the tools to make ethical decisions and to navigate those tough situations we talked about earlier.
So it's not just about protecting the public. It's also about empowering engineers to be ethical leaders.
That's exactly right. It's about creating a more responsible and ethical engineering profession as a whole.
Okay, so we've established the why behind engineering ethics. But let's flip the script for a second. Are there ever situations where being ethical can backfire or create disadvantages for engineers?
Oh, absolutely. Sticking to your principles can definitely lead to some tricky situations. Sometimes doing what's right clashes with business goals.
Right, like if the most ethical solution is also the most expensive one.
Exactly. They can put an engineer in a tough spot, trying to balance their ethical obligations with the demands of their job.
It's like that age-old dilemma, profits versus principles.
Exactly. And in some cases, it might even lead to an engineer losing their job if their company prioritizes the bottom line over ethical conduct.
That's a tough reality. It takes real courage to stand up for what you believe in when your livelihood is on the line.
You said it. It's not always easy, but it's incredibly important.
Okay, so there are definitely challenges.
Right.
What else makes navigating those ethical waters tricky for engineers?
Well, the ever-accelerating pace of technological advancement doesn't help.
It's like they're trying to hit a moving target with those ethical guidelines.
You got it.
Hmm.
It seems like every day brings new technologies and innovations, each with its own set of ethical questions.
It's a lot to keep up with.
It is. But despite those challenges, the benefits of upholding ethical standards far outweigh the potential downside.
Right. Ultimately, it's about doing what's right for people and the planet.
Exactly. It's about using engineering to make the world a better place. And that's something worth fighting for.
Okay, so we've talked about the importance of engineering ethics and the challenges engineers face. But how do those ethical issues actually show up in the real world?
That's a great question. The article distinguishes between 2 main types, macro and micro.
Okay, break it down for me. What's the difference?
Macro-ethical issues are the big picture stuff, the societal level concerns.
Like, what are the ethical implications of artificial intelligence as a whole? That kind of thing.
Exactly. Or how do we ensure that engineering projects are environmentally sustainable? Those are the kind of questions that fall under macro ethics.
So it's about the impact of engineering on society as a whole. What are those microethical issues then?
Those are more about the everyday choices that engineers make in their work.
Okay, so give me some examples.
Well, it could be something as simple as being honest in reporting data or respecting intellectual property rights.
Right, so those are ethical dilemmas that might come up on a daily basis for an engineer.
Exactly. And it's important to remember that both macro and micro ethics are interconnected.
Right, because those individual choices ultimately contribute to the bigger picture.
That's exactly right. It's like those little decisions add up over time.
So it's about being mindful of those ethical considerations at every level.
Exactly. From the small, everyday choices to those big picture questions about the role of technology in society.
It's interesting to think about how engineering ethics moves from the classroom to the real world.
Yeah, it's not just some theoretical concept they teach in school.
It's something that shapes how engineers actually operate in their careers.
Absolutely. Universities often teach engineering ethics as a separate subject, helping students develop their moral compass.
Right, so it's about giving them the tools to navigate the ethical landscape they'll face in their professional lives.
Exactly. But it doesn't stop there. Those ethical considerations continue to shape their work long after they graduate.
So it's an ongoing process, not just a one-time lesson.
Absolutely. In professional settings, ethical principles guide everything from how engineers approach their projects to how they interact with clients and colleagues.
It's about understanding a company's social obligations, respecting intellectual property, and making decisions that prioritize public safety and well-being, like we've been talking about.
Exactly. It's about building things that work ethically, responsibly, and for the greater good.
Okay, I know you've got all the answers, so give it to me straight. What are the core ethical principles that every engineer should have on their radar?
Well, the article boils it down to 5 key ethics: honesty, accountability, public safety, integrity, and respect.
All right, I like it. A nice, simple framework. Break down what each of those means in the context of engineering.
Sure thing. First up is honesty. This one's pretty straightforward.
Yeah, I think most people get that one.
Right. But for engineers, it means being truthful in every aspect of their work, accurately reporting data, presenting findings transparently, and being upfront with clients and colleagues.
No fudging the numbers or sweeping problems under the rug.
Exactly. Honesty is the foundation of trust.
Okay, what about accountability?
Accountability means taking responsibility for your actions, owning up to mistakes, and working to make things right.
So no passing the buck when things go wrong.
Right. It's about acknowledging your role and taking steps to fix the problem.
Makes sense. What's next on the list?
Public safety, maybe the most important principle of all.
Yeah, that one seems pretty crucial, especially when you think about the kinds of things engineers build.
Exactly. Engineers have a moral obligation to put the well-being of the public above all else. Their designs and creations should never put people's lives or health at unnecessary risk.
So it's about putting people before profits, deadlines, or personal gain.
Absolutely. Safety should always be the top priority.
Okay, what about integrity?
Integrity is all about sticking to your ethical principles, even when it's tough.
So it's about doing the right thing even when no one is watching.
Exactly. It's about resisting the temptation to cut corners, compromise safety standards, or cave to pressure from those who might not share those ethical values.
It's about having a strong moral backbone.
Exactly. It's about doing what's right, even when it's difficult.
Okay, last but not least, respect. What does that look like in engineering?
Respect is about treating everyone you interact with, colleagues, clients, the public, with dignity and consideration.
So it's about valuing diverse perspectives, listening to concerns, and fostering an environment where everyone feels safe to speak up.
Exactly. It's about creating a culture of respect, both within the engineering profession and in our interactions with the wider world.
Those 5 principles, honesty, accountability, public safety, integrity, and respect, seem like a pretty solid ethical foundation for any engineer.
I'd say so. And these principles aren't just for engineers. They're valuable guidelines for anyone facing ethical dilemmas in their personal or professional lives.
Good point. Okay, now I'm sure our listeners are probably thinking, this is all well and good, but how does it actually play out in the real world?
Right. It's time to get into some real-world examples, and the article has a whole section on frequently asked questions about engineering ethics, which is perfect for that.
Okay, let's dive into some of those common queries.
I'm ready when you are. Fire away.
Great. First up, the article talks about different types of engineering ethics. Can you break those down for us?
Sure. It focuses on 3 main categories: technical, professional, and social ethics.
Okay, 3 types of ethics. I'm intrigued. Tell me more.
So, technical ethics is all about the specific considerations related to well, technical aspects of engineering.
Like making sure your calculations are accurate or that you're using the right materials for a bridge.
Exactly. It's about the nuts and bolts of ethical engineering practice.
Gotcha. What about professional ethics?
Professional ethics is more about the standards of conduct that engineers are expected to uphold as members of a professional community.
Okay, so it's like the unwritten rules, the code of conduct for engineers.
Right. It's about things like maintaining confidentiality, avoiding conflicts of interest, and generally acting in a way that reflects well on the profession.
So it's about upholding the reputation of engineers as ethical and trustworthy professionals.
Exactly. And then there's social ethics, which is maybe the broadest category.
Okay, so what does that encompass?
Social ethics is about the responsibilities that engineers have to society as a whole.
So it's about considering the broader impact of engineering on the environment, on public health, on social justice, all of that.
Exactly. It's about recognizing that engineering doesn't happen in a vacuum.
Right. It has real-world consequences that extend far beyond the individual project or the company's bottom line.
Precisely. So those are the three main types of engineering ethics: technical, professional, and social.
Like a three-legged stool. They all need to be strong to support ethical engineering practice.
That's a great analogy. And they all play a role in those tough decisions engineers have to make.
Okay, another question that often comes up is, what are the benefits of studying engineering ethics? Why should engineers bother with this stuff?
Well, besides the obvious benefits of, not building bridges that collapse or creating products that harm people.
Those seem like pretty good reasons to me.
Right. But beyond avoiding those catastrophic failures, studying engineering ethics helps engineers develop their critical thinking skills.
So it's not just about learning a set of rules. It's about developing a way of thinking about ethical problems.
Yeah. Exactly. It helps them anticipate potential ethical conflicts, analyze different courses of action, and make choices that are aligned with their values.
So it's like giving them a toolbox for making tough decisions in those gray areas where there's no easy answer.
Exactly. And it's also about building trust with the public, which is something we talked about earlier.
Right, because people need to know that engineers are taking those ethical considerations seriously.
Exactly. It's about demonstrating that you're committed to doing the right thing, even when it's difficult.
Okay, one last question before we move on.
Hmm.
Is there a golden rule of engineering ethics, like one overarching principle that sums it all up?
Actually, there is. It's often called the rule of reciprocity.
The rule of reciprocity. Sounds fancy. What's that all about?
It's basically the idea of treating others as you would like to be treated.
Oh, I've heard that one before. Seems pretty straightforward.
Right. But in the context of engineering, it takes on a whole new meaning. It's about considering the impact of your work on others and making decisions that you would be comfortable with if you were on the receiving end.
So it's like, don't design a product that you wouldn't want your own family to use.
Exactly. It's a simple but powerful principle that can guide engineers in countless situations.
Okay, I like it. A golden rule for engineering ethics.
Right. It's all about empathy and recognizing that our actions have consequences for others. So we've been talking about this golden rule, but how does engineering ethics actually differ from ethics in general?
Yeah, good point. Is it just a subset of ethics, or is there something unique about it?
It's definitely not just a subset. There are some really distinct challenges that engineers face when it comes to ethics.
Okay, like what? What makes it different for engineers?
Well, one big difference is the sheer scale of responsibility they often have. Think about it. Their work can impact the safety and well-being of huge numbers of people.
Right, like if a bridge collapses or a power plant malfunctions, it's not just a minor inconvenience, it can be a major disaster.
Exactly. And that level of responsibility adds a whole other layer of complexity to those ethical considerations.
A lot of pressure.
It is. And then you add in the fact that engineering is all about pushing boundaries, creating new technologies and solutions.
Which is great. But it also means constantly encountering new ethical dilemmas that we've never even thought about before.
That's right. It's like the ethical landscape is constantly shifting as technology advances.
So engineers kind of have to be on their toes, ethically speaking.
They do. It's not just about knowing the rules. It's about anticipating the ethical challenges of technologies that haven't even been invented yet.
Wow, that's a lot to ask. It's like trying to predict the future.
It is, in a way. But that's part of what makes engineering ethics so fascinating.
Okay, so we've talked about the scale of responsibility and the rapid pace of technological change. What other unique challenges do engineers face when it comes to ethics?
Well, another big one is that idea of social responsibility. It's not just about building something that works, it's about considering the broader impact on society and the environment.
Right. It's about recognizing that engineering projects don't exist in a vacuum. They have ripple effects that can be felt far and wide.
Exactly. So engineers have to be thinking about those ripple effects, asking themselves, how will this project impact the community, the environment, the future?
So it's about taking a long-term perspective, considering the unintended consequences of their work.
Absolutely. It's about recognizing that engineering has the power to shape our world, for better or for worse.
Okay, so the scope of engineering ethics is pretty broad. Where does it begin and end?
That's a tough question. It really encompasses everything from an engineer's personal conduct to the global impact of their work.
So it starts with individual engineers making ethical choices in their day-to-day work.
Exactly. It's about being honest, avoiding conflicts of interest, and always putting safety first.
But it doesn't stop there, right?
Right. It also extends outward to how engineers design systems, how they interact with colleagues and clients, and how they engage with the public.
So it's about creating a culture of ethical practice within engineering organizations and the profession as a whole.
Absolutely. It's about making ethics an integral part of the engineering process, not just an afterthought.
Okay, I'm starting to get a clearer picture of how far-reaching engineering ethics really is. But let's get even more specific. Can you give us some real-world examples of how these ethical principles play out in the day-to-day work of engineers?
Sure. One area where it comes up all the time is confidentiality. Engineers often work with sensitive information like trade secrets, proprietary designs, client data, all sorts of things they have to keep confidential.
Right, because if that information gets out, it could harm the company, their clients, even the public in some cases.
Exactly. So maintaining confidentiality is a big part of being an ethical engineer.
It's like that doctor-patient confidentiality,
Mm-hmm.
but for engineers.
Yeah, that's a good way to think about it. It's about building trust and protecting sensitive information.
Okay, confidentiality makes sense. What are some other real-world examples?
Another one is intellectual property. Engineers need to respect the intellectual property rights of others.
So no stealing designs or ideas, no copying without permission, all that.
Right. It's about giving credit where credit is due, being honest about your sources, and protecting those patents and copyrights.
Okay, those are good examples of those microethical issues we were talking about earlier, the everyday dilemmas that engineers face.
Exactly. But remember, there are also those macroethical issues, the ones that deal with the bigger societal concerns.
Right, the big picture stuff. Let's zoom out and talk about those for a bit.
Okay, one that's impossible to ignore these days is sustainability.
Yeah, that's a huge one. Climate change, resource depletion, pollution, all of that.
Exactly. And engineers have a crucial role to play in addressing these challenges. They're the ones designing the systems, the products, the infrastructure that can either contribute to those problems or help solve them.
Right, so it's about designing things that are environmentally responsible, that minimize their impact on the planet.
Exactly. It's about thinking long term, using renewable resources, minimizing waste, and designing for a circular economy.
It's about building a future that's sustainable for generations to come.
That's right. And it's not just about doing the bare minimum to comply with regulations. It's about going above and beyond, constantly innovating to find better, more sustainable solutions.
So it's about making sustainability a core value in engineering, not just a checkbox on a form.
Absolutely. And this is where those macroethical considerations really come into play. It's about recognizing that engineers have a responsibility to the planet, to future generations, not just to their clients or their employers.
Right, because ultimately we're all interconnected. What we do today impacts the world we'll live in tomorrow.
Exactly. And that brings us to another really big one, the impact of technology on society as a whole.
Right, because technology isn't inherently good or bad. It's how we use it that matters. And engineers are often the ones creating those technologies, so they have a huge influence on how they're used.
Absolutely. They have a responsibility to think critically about the potential consequences of their creations.
So it's about asking those tough questions like, could this technology be used for harmful purposes? Will it create new inequalities? Will it erode privacy?
Exactly. It's about anticipating those potential problems and designing solutions that minimize the risks and maximize the benefits.
It's about being proactive, not reactive.
That's right. And it's also about engaging with the public, having open and honest conversations about the potential impacts of new technologies.
So it's not just about building the coolest new gadget. It's about considering how that gadget might change our lives for better or worse.
Exactly. It's about recognizing that technology is a powerful tool, and it needs to be wielded responsibly.
Okay, so we've talked about some pretty weighty stuff here. Sustainability, the impact of technology on society, it's a lot to grapple with. So how can engineers actually navigate these incredibly complex ethical dilemmas? How do they make the right choices when faced with all these pressures? Clients, deadlines, budgets, even their own ambitions.
That's the million-dollar question, isn't it? And there's no easy answer, no magic formula, but there are definitely strategies and resources that can help.
Okay, let's hear them. What can engineers do to make sure they're making ethically sound decisions?
Well, first and foremost, it starts with developing a strong moral compass.
Okay, so that's about having a clear sense of right and wrong, knowing what you stand
Yeah,
for.
exactly. It's about being able to identify those ethical gray areas
Right.
and having the courage to do what's right, even when it's difficult.
Easier said than done, right?
Oh, definitely. But it's essential for navigating those tricky situations where there's no clear-cut answer.
Okay, so a strong moral compass is key. What else?
Well, it's also important to seek out ethical guidance when you need it.
So don't be afraid to ask for help.
Exactly. Talk to mentors, colleagues, professional organizations, whoever you trust, to give you a sound perspective.
It's like having a sounding board, a way to bounce ideas off someone else and get their take on the situation.
Right. Sometimes just talking it through with someone else can help you see things more clearly.
Makes sense. What else can engineers do to stay on the ethical straight and narrow?
Well, it's not just about individual actions. It's also about creating a culture of ethical practice within engineering organizations themselves.
So it's about making ethics part of the company culture, not just something you talk about once a year during a training session.
Exactly. It's about setting clear ethical standards, providing ethics training for employees, and creating mechanisms for reporting and addressing ethical concerns.
So it's about creating an environment where people feel comfortable speaking up if they see something that doesn't seem right.
Right. It's about making it clear that ethical conduct is valued and rewarded.
Okay, so a strong moral compass, seeking out ethical guidance, and creating a culture of ethical practice within organizations. Anything else?
One more thing, and it might be the most important of all: ongoing learning and reflection.
So it's not just about learning the rules once and then checking that box.
Not at all. The field of engineering ethics is constantly evolving as technology advances, so engineers need to stay up to date on those new challenges, new perspectives, new best practices.
So it's about being a lifelong learner when it comes to ethics.
Absolutely. It's about continuously refining your understanding of ethical principles and adapting your decision-making processes to keep pace with a rapidly changing world.
Okay, we've talked a lot about following ethical guidelines, but what about leading the way? What does it mean to be a moral leader in the field of engineering?
That's a great question. Moral leadership in engineering is about going above and beyond simply following the rules. It's about setting a positive example for others, inspiring your colleagues to prioritize ethical conduct, and advocating for ethical practices within your organization and the wider profession.
So it's about walking the talk, being a role model for others to follow.
Exactly. Moral leaders are the ones who demonstrate integrity, courage, and an unwavering commitment to doing what's right.
Okay, that sounds inspiring, but what does that actually look like in practice? Can you give us some concrete examples?
Sure, one example is having the courage to speak up against unethical practices, even when it might jeopardize your position or your reputation.
Wow, that takes guts.
It does. But moral leaders are willing to take those risks because they know that doing the right thing is more important than protecting their own interests.
So it's about putting principles above personal gain. What else does moral leadership look like?
It's also about being a mentor and a guide for others, helping less experienced engineers develop their own ethical compass and navigate those tough situations we talked about earlier.
Right, because everyone needs a little guidance sometimes, especially when they're just starting out in their careers.
Absolutely. It's about passing the torch of ethical practice to the next generation.
Okay, speaking up against unethical practices, mentoring others, what else?
Another key aspect of moral leadership is advocating for ethical policies and practices within the organization. That might mean pushing for more robust safety protocols, advocating for greater transparency in decision-making, or challenging practices that prioritize profit over ethical considerations.
So it's about using your influence to create a more ethical workplace, to make sure that ethics is embedded in the company culture.
Exactly. Moral leaders are the ones who drive positive change from within, who constantly strive to make things better.
I love that vision. But it begs the question, What qualities make someone a moral leader in engineering? Is it something you're born with, or can it be cultivated?
That's a question that's been debated for centuries. Are leaders born or made? But when it comes to moral leadership, I think it's a bit of both.
Okay, so some people might naturally be more inclined towards leadership, but those moral leadership skills can also be developed and strengthened over time.
Exactly. It's like a muscle you can exercise. The more you practice making ethical decisions, the stronger your moral compass becomes.
So it's about making a conscious effort to develop those ethical muscles, those habits of mind that lead to responsible decision-making.
Right. And there are certain qualities that are particularly important for moral leadership in engineering.
Okay, I'm all ears. Give me the rundown. What are those key qualities?
Well, one of the most important is integrity.
Integrity. Yeah, that makes sense. It's about being honest, trustworthy, and doing what's right, even when it's hard.
Exactly. Moral leaders are the ones who walk the talk. Their actions are consistent with their words, and they inspire trust in those around them.
They're the real deal. What else is essential for moral leadership?
Courage is another big one.
Courage. Okay, why courage?
Because moral leaders often have to stand up for what they believe in, even when it's unpopular or risky. They might have to challenge authority, speak truth to power, or make decisions that go against the grain. That takes courage.
Right, it's not always easy to be the one who says, this isn't right, especially when you're going up against people who have more power or influence than you do.
Exactly. But moral leaders are willing to take those risks because they know that doing the right thing is more important than protecting their own careers or reputations.
Okay, integrity and courage, those are two big ones. What else?
Empathy is also crucial for moral leadership.
Empathy.
Mm.
Okay, I can see how that would be important in any kind of leadership role, but how does it apply specifically to engineering?
Well, it's about being able to understand and consider the perspectives of others, especially those who might be affected by your decisions.
So it's about putting yourself in other people's shoes, trying to see the world from their point of view.
Exactly. It's about recognizing that your actions as an engineer have consequences for others, and those consequences can be far-reaching and complex.
So it's about taking a holistic view, considering the human impact of your work, not just the technical aspects.
Right. And it's also about being able to listen to and respond to the concerns of others, even when those concerns are different from your own.
So it's about being open-minded, willing to consider different perspectives, and being able to find solutions that work for everyone involved.
Exactly. Empathy is a key ingredient in building trust and creating a more just and equitable world.
Okay, integrity, courage, empathy. What else is on that list of qualities for moral leadership?
Another important one is having a strong sense of purpose.
Purpose. Okay, what do you mean by that?
Well, moral leaders have a clear vision for a better future, and they're passionate about using their skills and their influence to make that vision a reality.
So it's about seeing the big picture, not just focusing on the immediate task at hand.
Exactly. It's about recognizing that engineering can be a force for good in the world, and it's about being committed to using your skills to make a positive difference.
So it's about more than just building bridges and designing software. It's about building a better world.
That's right. It's about using your engineering expertise to address those big challenges we talked about earlier. Climate change, poverty, inequality, all of that.
So it's about being a problem solver, an innovator, but also a humanitarian.
Exactly. Moral leaders are the ones who see those problems and are determined to find solutions, even if those solutions are difficult or unconventional.
Okay, so integrity, courage, empathy, purpose,
Right.
anything else? I'm guessing communication skills are probably important too.
You're absolutely right. Moral leaders need to be able to communicate their vision and their values effectively. They need to be able to explain their reasoning, persuade others to embrace ethical practices, and inspire them to act.
So it's not just about being a good engineer. It's about being a good communicator, a good storyteller.
Exactly, because at the end of the day, moral leadership is about influencing others, about getting people to buy into your vision for a more ethical and responsible engineering profession. And that takes strong communication skills.
Okay, this has been an incredibly insightful exploration of moral leadership in engineering. I'm feeling inspired. But I think it's time to bring it back down to earth a little and ground these ideas in a real-world example.
I agree. Sometimes the best way to understand complex ethical issues is to examine how they played out in a specific event.
Exactly. And for that, I think it's important to discuss the Chernobyl disaster, a tragic event that serves as a stark reminder of what can happen when ethical considerations are overlooked or ignored in engineering.
Chernobyl is a crucial case study for anyone interested in engineering ethics. It's a reminder of the immense responsibility engineers carry and the far-reaching consequences that can arise from even seemingly small ethical lapses.
Before we get into the specifics, let's set the scene for our listeners who might not be familiar with the event.
Sure. The Chernobyl disaster was a nuclear accident that occurred on April 26, 1986, at the Chernobyl nuclear power plant near the city of Pripyat, in what was then part of the Soviet Union.
This was during the Cold War, a time of heightened tensions between the Soviet Union and the West. It feels like a lifetime ago.
It does. And the accident itself was a catastrophic explosion and fire that released a massive amount of radioactive material into the atmosphere, contaminating vast areas of Ukraine, Belarus, and Russia.
It's considered the worst nuclear disaster in history, both in terms of immediate casualties and long-term health effects.
Tragically, that's true. The disaster had a devastating impact on human lives, the environment, and even the global perception of nuclear power. It's a tragedy that continues to shape our understanding of safety and responsibility in engineering.
Okay, now that we have some context, let's dive into the ethical issues at play. What factors contributed to this catastrophic event? Could it have been prevented?
That's a complex question, and there's no single easy answer. Multiple factors converged to create the perfect storm that led to the Chernobyl disaster. Some were technical, like design flaws in the reactor itself. Others were organizational, like a culture of secrecy that discouraged open communication about safety concerns. And still, others were rooted in human error and a disregard for safety protocols during a crucial test.
So it wasn't just one thing that went wrong. It was a cascade of failures, a combination of technical shortcomings, organizational dysfunction, and human mistakes.
Exactly. And when you peel back the layers, you see that many of these factors stemmed from ethical lapses, both at the individual and organizational levels. Choices were made, priorities were set, and corners were cut, all of which ultimately contributed to the tragedy.
It's a stark reminder that ethics isn't just about abstract principles. It's about making concrete choices that have real-world consequences, sometimes on a massive scale.
You're absolutely right. So let's take a closer look at some of the key ethical failures that contributed to the Chernobyl disaster. One of the most glaring was the prioritization of political and economic goals over safety concerns.
So it was a classic case of cutting corners to meet deadlines and stay within budget, even if it meant compromising safety.
Sadly, yes. There was immense pressure from Soviet authorities to complete the Chernobyl plant quickly and cheaply. This led to a series of compromises, from relaxed safety standards to inadequate oversight of the construction process.
It's a tragic example of how political expediency and economic pressures can override ethical considerations, even when the stakes are incredibly high.
It is, and it highlights the importance of having strong ethical leadership in engineering organizations, individuals who are willing to push back against those pressures and prioritize safety, even when it's unpopular or inconvenient.
Right, because someone has to be the voice of reason, the one who says, hold on, we're moving too fast, or we need to invest more in safety, even if it impacts the bottom line.
Absolutely. But strong leadership isn't enough. Another crucial factor is transparency and open communication about safety concerns.
So were there people who knew about the risks but didn't speak up or weren't listened to?
That's exactly what happened. Within the Soviet nuclear industry at that time, there was a culture of secrecy and fear that discouraged open discussion of safety issues. Whistleblowers were often silenced or punished, and concerns raised by engineers and technicians were frequently ignored or downplayed by those in positions of authority.
That's a recipe for disaster. If people are afraid to speak truth to power, then problems can fester and grow until they reach a breaking point.
You're absolutely right. Open communication is essential for creating a safety culture where everyone feels empowered to raise concerns without fear of retaliation, where problems are addressed proactively, and where continuous improvement is valued.
So it's not just about having rules and regulations. It's about creating an environment where those rules are taken seriously and where everyone feels a sense of responsibility for upholding them.
Exactly, and unfortunately, that wasn't the case at Chernobyl. Another contributing factor was a blatant disregard for established safety protocols during the test that led to the explosion.
So there were procedures in place to prevent this kind of accident, but they were ignored. Why?
The operators of the Chernobyl plant, under pressure to complete the test, deviated from approved procedures. They disabled several safety systems and made a series of operational errors, creating a highly unstable situation.
It's a tragic reminder that safety protocols are there for a reason. They're based on experience, testing, and a deep understanding of the risks involved. Ignoring them, even for seemingly good reasons, can have devastating consequences.
It's a lesson that's been learned time and again in engineering, often at a terrible cost. It highlights the importance of not only establishing robust safety procedures, but also ensuring that everyone involved understands their importance and adheres to them without exception.
Okay, we've discussed some of the key ethical failures that contributed to the Chernobyl disaster. The prioritization of political and economic goals over safety, the lack of transparency and open communication, and the disregard for established safety protocols. It's a sobering picture.
It is. But as devastating as this disaster was, it offers invaluable lessons for engineers and leaders today. It's a stark reminder of what's at stake when ethical considerations are neglected, and it's a call to action to prevent such tragedies from happening again.
So let's shift gears and talk about what can be learned from Chernobyl. What lessons can we draw from this tragedy to prevent similar disasters in the future?
One of the most important takeaways is the need for robust and truly independent safety oversight, especially in high-risk industries like nuclear power. It's not enough to simply have safety protocols in place. You need an independent body to ensure that those protocols are being followed and that safety is never compromised for other priorities.
So it's about creating a system of checks and balances to make sure that no one individual or organization has unchecked power and that safety is always the top priority. Who would be responsible for this independent oversight?
Ideally, it should be a regulatory agency or a committee composed of experts from various disciplines, people who are free from political or economic pressures that might compromise their judgment. They would have the authority to inspect facilities, review safety procedures, investigate accidents, and enforce compliance with safety regulations. Their sole focus should be on ensuring public safety.
Right, because if that oversight comes from within the organization itself, there's always the risk that profit motives or production deadlines might overshadow safety concerns.
Exactly. Another crucial lesson from Chernobyl is the importance of fostering that strong safety culture we talked about earlier. It's not just about rules on paper, it's about creating an environment where safety is everyone's responsibility, where open communication about risks is encouraged, and where employees feel empowered to raise concerns without fear of repercussions.
We talked about transparency and open communication, but can you elaborate on what else goes into creating this kind of culture?
It's about fostering a sense of ownership and responsibility at all levels of the organization. Everyone, from the CEO to the newest employee, needs to understand that safety is paramount and that they have a role to play in upholding it. It also requires leadership that sets the right tone and leads by example, demonstrating that safety is truly a core value, not just lip service.
It's about weaving safety into the fabric of the organization, making it part of the DNA, not just a box to check off on a compliance form. What else can be done to prevent tragedies like Chernobyl?
Another key takeaway is the importance of designing systems with inherent safety features.
Inherent safety features, what does that mean?
It means building in layers of protection, redundancies, and fail-safes that prevent accidents, even in the event of human error or equipment malfunction. It's about anticipating potential problems and designing systems that are inherently resilient and forgiving.
So it's like having backup systems, emergency shutoffs, and multiple layers of protection to ensure that a single point of failure doesn't lead to a catastrophic event. It's about making it difficult for accidents to occur in the first place.
Precisely. And this approach to safety, often called defense in depth, has become standard practice in many engineering fields. It's a recognition that human error is inevitable, and systems need to be designed to account for that fallibility.
Okay, so we've got independent oversight, a robust safety culture, and inherent safety features. Are there any other crucial lessons from Chernobyl that we should keep in mind?
Absolutely. One more critical takeaway is the importance of having effective emergency preparedness and response plans.
That makes sense. Even with the best safety precautions, accidents can still happen. So it's crucial to be prepared to handle them swiftly and effectively to minimize the damage.
Exactly. This includes having clear and well-rehearsed procedures for evacuations, containment of hazardous materials, and treatment of those who have been injured or exposed. It also involves having a transparent and timely communication plan to keep the public informed during and after an emergency.
Right, because clear communication during a crisis is essential for preventing panic, coordinating relief efforts, and maintaining public trust.
Exactly. And it's not just about having plans in place. It's about regularly testing those plans, running drills, and ensuring that everyone involved knows their role and can execute it effectively under pressure.
It's about being prepared for the worst while hoping for the best. And that preparation can make all the difference in mitigating the damage and saving lives.
Absolutely. The Chernobyl disaster, while a tragedy, has provided invaluable lessons for engineers and policymakers around the world. It's a stark reminder that ethical considerations are not just philosophical abstractions. They have tangible, real-world consequences that can be the difference between safety and disaster.
Right. It's a sobering reminder that engineers have a profound responsibility to design and build systems that are not only functional and innovative, but also safe, sustainable, and ethically sound. They have the power to shape our world, and that power must be wielded responsibly.
I couldn't agree more. The decisions engineers make today will have far-reaching implications for generations to come.
Welcome back to the Deep Dive. We've been unpacking the world of engineering ethics, from those basic principles to the lessons learned from Chernobyl.
And it's clear that ethical choices aren't just something for the classroom. They have a real impact, shaping history in ways we can't always predict.
It's true. Those decisions engineers make, they touch all of our lives. So let's zoom out a bit, look at the bigger picture. What global issues are engineers facing right now where ethics are front and center?
Well, climate change is a big one, obviously. Can't really talk about global issues without it.
Right. And it's not just about scientists and policymakers anymore. Engineers have a huge role to play in tackling this.
Absolutely. Mitigating climate change, helping humanity adapt, it all depends on engineers making ethical choices. It's where those macro-ethical considerations become reality.
Right, like it's not enough to just build things anymore. It's about building them in a way that doesn't wreck the planet.
Exactly. So we're talking sustainable systems, cutting those carbon emissions, developing renewable energy sources, all that good stuff.
Makes sense. But it's not just about the technology itself, right? It's about how it's used, who benefits from it.
Oh, definitely. And that brings up some really thorny issues like geoengineering.
Geoengineering, that sounds intense.
It is. We're talking about large-scale interventions to manipulate the Earth's climate system.
Wow. I can see how that would raise some serious ethical questions.
You're telling me? I mean, think about it. Do we have the right to tinker with the planet like that? What about unintended consequences? It's a debate where engineers are at the heart of it all.
Okay, so climate change is huge, but it's not the only ethical challenge on a global scale, right?
Right. Another big one is access to clean water and sanitation.
Yeah, it's easy to take for granted, but billions of people still don't have reliable access to clean water.
It's a basic human right that's not being met for a huge chunk of the population, and engineers have the skills to help change that.
So it's about developing those water purification technologies, designing sustainable sanitation systems, making sure those solutions can be used in all sorts of environments.
Exactly. But it's more than just the technical side, too. We have to think about the social and economic factors, make sure those solutions actually worked for the communities they're meant for.
Right. It's about collaboration, understanding local needs, not just imposing a technical fix that might not fit the context.
Couldn't said it better myself. And then, of course, there's the AI revolution that's upon us.
AI, artificial intelligence, yeah, that's everywhere now.
Exactly. From those self-driving cars you mentioned earlier to medical diagnoses, the potential is mind-blowing. But it comes with a whole new set of ethical considerations.
Right, because AI is only as good as the data it's trained on, the algorithms that drive it. There's potential for bias, for misuse, even for unintended consequences that we can't foresee yet.
Exactly. Privacy concerns, job displacement, even the potential for AI systems to be used in harmful ways. These are all ethical challenges that engineers have to grapple with.
So it's not just about building smarter machines, it's about building them ethically.
Absolutely. It's about making sure AI is used to benefit humanity as a whole, not just a select few. And that responsibility lies squarely on the shoulders of engineers.
Okay, climate change, clean water, AI. Any other biggies on the engineering ethics radar?
Well, cybersecurity is becoming increasingly urgent.
Yeah, with everything being connected these days, it seems like we hear about a new data breach or hack every other day.
It's a constant cat and mouse game. And engineers are on the front lines, designing secure systems, coming up with those cybersecurity protocols, educating people about how to protect themselves.
So it's a shared responsibility. Engineers build those defenses, but we all have to do our part to stay safe online.
Exactly. And then there's the ethical aspect, too. We want security, but we don't want to live in a surveillance state. Finding that balance is crucial.
Right. It's about protecting people's privacy and freedom while also keeping them safe from cyber threats. Not an easy task.
Not at all. But it's a challenge that engineers are increasingly having to face.
Okay, so we've covered a lot of ground here. Climate change, access to clean water, the rise of AI, cybersecurity. A lot to think about.
It is, but it's also exciting. I mean, think about the potential for engineers to make a real difference in the world, to use their skills to tackle these big challenges.
I like that perspective. It's not just about avoiding disaster. It's about using engineering to create a better future.
Exactly. It's about harnessing the power of technology for good.
Okay, but before we get too carried away with all that optimism, I have one final, thought-provoking question. As technology keeps advancing at this crazy pace, what new ethical dilemmas might engineers face down the road?
That's the big question, isn't it? The one that keeps me up at night. As we delve deeper into these emerging fields like gene editing, nanotechnology, synthetic biology, we're entering uncharted territory.
It's like we're opening Pandora's box, but with technology instead of mythical creatures.
Right, and we need to be prepared for the ethical challenges that come with it. These advancements raise questions about what it means to be human, the limits of science, the potential for both progress and peril. It's mind-boggling, really.
Okay, give me a glimpse into that future. What specific dilemmas might pop up?
Well, think about gene editing, for instance. Amazing potential for curing diseases. But what about using it to enhance human capabilities? Creating designer babies, altering traits, even blurring the lines between human and machine?
Wow, that's heavy stuff.
It is. We have to ask ourselves, who gets access to these enhancements? Does it create a new class divide? What are the unintended consequences?
It's almost like we need a whole new set of ethics to deal with these possibilities.
We might. And then there's nanotechnology, manipulating matter at the atomic level. Incredible potential, but also risks.
Like what?
Well, imagine self-replicating nanobots that could consume anything in their path. Or nano-sized surveillance devices that could be implanted without our knowledge.
Okay, now that's straight out of a sci-fi movie.
It might sound far-fetched, but these are possibilities we have to consider. The ethical implications of nanotechnology are huge.
And what about synthetic biology? Designing artificial life forms. That's another one that pushes the boundaries of what we consider possible.
It is. We're talking about creating new organisms, re-engineering existing ones, even blurring the lines between life and non-life. It raises questions about what we consider sacred, the potential for unintended consequences, the risks of creating technologies that could be used for harm.
It's a lot of responsibility.
It is, and these are just a few examples. As technology continues to advance, we can expect even more ethical dilemmas to emerge, ones we haven't even imagined yet.
So how do we prepare for that? How do we ensure that ethics keeps pace with all this innovation?
Well, for starters, we need to keep having these conversations, open, honest dialogues about the ethical implications of emerging technologies. We need engineers, ethicists, policymakers, everyone at the table.
So it's about bringing diverse perspectives together, having those tough conversations now, before it's too late.
Exactly. And it's about integrating ethical thinking into engineering education from day one. Those future engineers need more than just technical skills. They need a solid ethical framework to guide their work.
It's about building that ethical foundation, making it a core part of what it means to be an engineer.
Absolutely. And we need to foster a culture of humility and responsibility within the profession, recognizing that we don't have all the answers, that our creations can have unintended consequences.
Right. It's about proceeding with caution, learning from our mistakes, being willing to change course when necessary. We're shaping the future with technology, and that's a huge responsibility.
Couldn't agree more.
Well, this has been an amazing exploration of engineering ethics. We've covered so much, from those basic principles to the lessons learned from Chernobyl to the mind-blowing potential and ethical challenges of emerging technologies. It's clear that ethics isn't just some side note. It's central to the very essence of engineering and its impact on the world.
Absolutely. And I think the big takeaway here is that the future of technology is being shaped right now, and it's up to all of us, not just engineers, to make sure it's a future that benefits humanity and the planet.
That's a powerful message to end on. The choices we make today will determine the world we inherit tomorrow. So let's choose wisely, ethically, with the well-being of everyone in mind.
Well said.
Thanks for joining us on this deep dive into engineering ethics. Until next time, keep exploring, keep questioning, and keep those ethical considerations top of mind.